Hi, this is Florian. In this video I would like to show you how to set up the transcription site quantification. Here we need two files. The first, the averaged image of the individual mRNA molecules. The second, the summary file for all the estimated parameters for those mRNAs. We generated those files earlier in the tutorial on the batch processing of the mature mRNA. For this tutorial here I would like to use data on a larger data set that you can find in the example datasets, FISH data results nascent. Those files are identical except that I generated them on 7,000 individual mRNA molecules in roughly 150 cells. Before we get started, we update the results folder in FISH-QUANT. We do that by folders, folder for results. We change that from results mature to results nascent. Then we open the transcription site quantification module from Tools, Transcription Site Quantification. This opens a new user interface. Here the outline file that has been used in the main FISH-QUANT interface is displayed. Other outline files can be loaded if you wish. We then specify the image of the individual mRNA molecules stored in the results nascent folder. We then specify the parameters. Those are the experimental parameters imported from the outline files, so they don't have to be changed. Then we have to define the background of the averaged mRNA image. This can be simply done in ImageJ or other image processing tools. I show you how to do this. You take your image, you open it in ImageJ. It opens the C-stack. Then you simply select a region far away from the actual signal in the corner. You plot here the z-axis profile, so the intensity of this region in the individual z-planes. See, this value fluctuates very little between 243 and 244. So we use 244 as an estimate of the background for our image. We define this here as a scalar value, 244. Then we define the amplitudes of the individual mRNA molecules. They're contained in the results file that we already have in the results nascent folder. We open this file. FISH-QUANT will extract the amplitudes, plotted them as a histogram. Overlaid in red is the best fit with a skewed normal distribution. Then we have to process those settings. This takes a little while, so while this happens I will just pause the video and come back. Now the processing is done. The figure you see is just a brief overview of the averaged image that was read in and how it fits with a 3D PSF. This is really only to illustrate that the right file was read in. We now have all of the settings specified. We can save those settings and use them in the batch processing module, or if you wish you can also analyze transcription sites directly here and change some of the parameters. For this I invite you to read the user manual to familiarize yourself with the details of those parameters. For now we just save the settings, save settings, and we will then use them in the batch processing module, which will be introduced in the next tutorial.